Hello. In this video, we'll look at a way to get around training cutoff dates by tiering large language models and using some basic capabilities around the LangChain project. For example, we can consider using Google's flagship PaLM models if we believe that those PaLM models know enough about our topic of interest, but fall back to OpenAI's large language models like GPT-4 if they seem to have more confidence around a subject matter. Finally, if all else fails, we can actually use information from the internet and feed it into one of these large language models to give it some context that it can use to answer our questions. Now, exactly how you tier these large language models is up to you, but the idea is that with just some basic code, we can have an adaptive approach and make sure that when we're getting information from our large language models and generative AI, we're using a system that actually understands the concept based on training cutoff dates. It's actually okay if we don't know the specific training cutoff date for these large language models, since the latest models from Google and OpenAI, like PaLM 2 and GPT-4, have a surprisingly good ability to understand what they don't know, as long as we set up the prompts correctly. So let's open up an IDE now and look at how we can set this up. I've created a new directory for a Git repository and will certainly share the code in the description of this video. We will build out this code step by step. The first thing we need to do is import some packages that we need. We're going to need the OS package for handling environment variables, such as our OpenAI API key. We're going to use tick token for counting tokens, since in that fallback option of using something like Wikipedia to provide the AI with context, we want to make sure that the context is within reasonable context windows. Then we're going to use the LangChain wrapper around Wikipedia to get that text information. Of course, you could get this from another library or source, and we're just going to use some basic LLM chains using LangChain. Deliberately, we're going to avoid using more advanced functionality in this LangChain library, just to keep this script as approachable as possible, even for folks that aren't as familiar with the LangChain project. Now I've got both OpenAI and Google's latest LLMs here. However, at the time of this recording, the Vertex AI LLM is actually in a pull request and it hasn't yet merged. So we're going to use a little bit of an unusual pip installation to get this package so that we have the Vertex AI capabilities in Google's LLM, even though this hasn't been released yet. Almost certainly, when you're watching this video, this will have been released, and so you can use the usual pip installation methods. Let's go ahead and install the libraries that we need. The tick token library, we can just use the latest release for that, and we'll also want to get the OpenAI library. For the LangChain installation, though, we're going to use a GitHub-based installation of that Harrison Vertex branch. Again, this is a little bit unusual, and you shouldn't need to do this because you're likely watching at a point in time where these models have been properly included in a LangChain standard release. Alright, so next up, we're going to need to think about a concept that we want to understand or analyze with these large language models. As a bit of a meta example, we're going to use LangChain, which is an especially nice example because this is a very recent project. If we look at the contributions for this project, they started in October 2022, so this is a very recent project, and therefore our LLMs of interest are pretty unlikely to have seen this concept before in their training datasets. Now, I've already in the background added the environment variable for the OpenAI API key. If you haven't done that yet, you could define this in code or just use bash commands in your terminal to define your API key. In any case, you will need that API key defined, and also you should use the gcloud init command to initialize your Google Cloud connection and authentication. Because we're using Google Cloud's Cloud Shell IDE, we already have that set up, so we're actually good and don't need any more authentication or configuration code. Next up, let's define the two models that we're going to be using in our analysis as LLMs. First is the OpenAI model, and we'll use the latest GPT-4. Again, this has a pretty good capability for self-reflection and understanding when there's a concept that goes beyond its training dataset. The Google large language model, specifically the one in Vertex AI, which at the time of this video is Palm 2, also has some pretty good self-reflection capabilities. Now, in both cases, we're going to use a prompt template like this to see if it understands a concept and have it provide a yes or no answer. We're going to ask, can you confidently provide an initial release year for some concept? In this case, we're providing LangChain as an example, but we could be looking at, say, music or album dates. In any case, we want to investigate if the LLM seems to understand a fact about the concept that we're asking it about. Now, if it does, we're going to use a from-scratch approach for generating a bit of a summary or purpose for this concept. And the prompt here is going to be, in one sentence, the concept is useful because it... The fallback approach with Wikipedia means providing the LLM with context and then asking it to summarize. So we're not really going to be taking advantage of the knowledge that's captured in the large language model itself directly. We're just going to be using those capabilities to infer and extract knowledge from the context that we provide in this case, a Wikipedia entry. Next, let's define the knowledge checks that we're going to use to discern what path we take in our analysis, and we'll do that for both OpenAI and the Google Palm model. We'll also write a little helper function for getting Wikipedia data, and importantly, we want to make sure the data we gather is within a token limit. If we have a really long Wikipedia entry for some sort of concept, we want to make sure that we're staying within context windows when we pass this context into our large language model of choice. So all this helper function is doing is collecting the data from the Wikipedia API wrapper until an additional line would exceed the token limit. Now we can start to define the logic and flow for our approach here, and this is going to be a little bit dependent on your context and which models are your favorites. We're going to build out a match case sort of set up like this. As one example, if the OpenAI seems to understand and the Google AI also seems to understand, then we're going to take some sort of action here and we need to define all the cases. Importantly, though, when neither model seems to understand the concept, that's where we're going to want to leverage the Wikipedia approach and passing in context. Let's start to fill out some of these cases. Here's the Wikipedia example. In addition to providing the answers from those knowledge checks for both OpenAI and Google, we're going to mention which case we're using and then print the response from that actual summarization. The other cases are going to be really similar here. Now, again, you may want to use more advanced capabilities in this LangChain library, but what's nice here is that we've got the dry principle in action. We're not repeating ourselves. We're able to use these prompt templates in a very clean way for both of our LLM models across OpenAI and Google. Similarly, we're only defining these models once at the beginning here, so this is a pretty lean approach and just requires a little bit of understanding about this LLM chain, which simply combines a model and a prompt template and passes in parameters for that prompt template. There is the chance, because these are general-purpose large language models, that we get a non-yes or no answer for this question. We'll ignore all text beyond the yes or no, but if the answer doesn't start with a yes or no, then we'll want to report that as an error. We need to get a definitive answer from those knowledge checks. This should be all set here. We should be able to run this Python script now if we have all the required libraries. And again, we're going to start with the LangChain concept as an example, since it's unlikely that either of these models knows about this project. All right, and we do need the Vertex AI package as well, so just one more pip install and the latest version of that package should be fine. It does include the latest large language model capabilities. And if you're using a new project, you need to enable Vertex AI, so we'll go ahead and do that in the console. Just search for Vertex AI or choose it in the navigation menu and then enable all recommended APIs. Once that API is enabled, let's go ahead and try again. And just one more install here. As you can see, the LangChain project uses a lot of libraries that aren't strict dependencies, depending on what capabilities you use. Finally, we see our answers here about LangChain. OpenAI had a rather verbose answer, but a no as far as its understanding of LangChain, and Google responded the same way. So we ended up using Wikipedia and OpenAI with the From Wikipedia prompt to have OpenAI give us a summary of this project, which it actually knows nothing about, presumably because of its training cutoff date in September 2021 for GPT-4. And we get a pretty good summarization here. It's a software development framework that simplifies applications with large language models, use cases such as document analysis, summarization, chatbots, and code analysis. This is great. We're having AI generate summaries of things it knows nothing about. Now, we can just as easily use this to understand concepts that have been around for much longer. So, for example, if we say iPhone, I would expect both models to understand this concept pretty well and understand the initial release year for the iPhone. But let's check and see what both models answer and which we end up going with. In this case, we're hitting that fallback value error where we have the OpenAI and Google knowledge checks printed out in case we don't get yes or no answers at the beginning of the sentences. Now, we could do a regex check potentially to see if we get the yes or no answer, which would fix this error. Instead, perhaps we adjust the prompt to say, answering only yes or no, can you confidently provide an initial release year for the concept? Let's see if this ends up changing the answer that we get. All right, so we do get yes across both models now, and we just have a small error in our code here. We do need to use the first 3 characters for this yes. But it's a step in the right direction. We're getting very succinct answers from both of our models, which is a good sign. Third time's the charm. We get yes from both our models, so we pass Google the from scratch prompt, asking it to draw on its own knowledge base, the knowledge that's in the large language model itself, to answer the question about why the iPhone is useful. Google says the iPhone is useful because it's a powerful and versatile device, and this seems like a pretty reasonable answer. So, hopefully you've seen through this tutorial how we can have models self-reflect to better align our questions with models that actually understand the concept based on what we can infer from their training corpus and training cutoff dates, and how we can use fallback mechanisms to still use generative AI, even in cases where we have really new concepts that are not included in these models' training sets. We'll keep an eye on the comment section for any questions and want to thank you for watching.